Right. These are the 0.5B notes for PreCalc. We're talking about intercepts and symmetry today. So examples 1 and 2, they're asking us to find the x and y intercepts. Remember on a graph that you have your x axis here and your y axis that direction. So x-intercepts anywhere it crosses or touches. Crosses or touches. So for our x-intercepts, we have the point right here, which I know is a little small. It looks like -4, 0. And then we have a point right here, which is 1. I'm writing all of these as ordered pairs. Sorry, -1. A lot of times you'll just see the numbers without the parentheses and the additional 0. For your y-intercept, looking for your up and down, anywhere it crosses or touches, that happens right there, which would be the point 0, 4. For example number 2, x-intercepts. Here we go. We're looking at that point right there, which would be -2, 0. And again, sometimes it's just going to ask you to type in the numbers. So sometimes it just asks for -2. So I'll do that example like that. Just make sure you're clearly reading the directions. And then the y-intercept, my graph does not cross the y-intercept, so I'm going to write an answer of none. All right, those are pretty easy to identify on a graph. Let's look at the next part. Let's do the same thing, but in an equation form. So how do I find intercepts? Give it an equation. For your x-intercepts, we will plug in 0 for y. And for your y-intercept, we're going to plug in 0 for x. So each of these will have 2 parts. You'll be finding the x-intercept and the y-intercept. So for your x-intercept, let's plug a 0 in for the y. 2x plus 3 times 0 equals 6. 3 times 0 is 0. I'll just get rid of that part right there. Divide by 2. X equals 3. Again, you can write your answer as 3. Or if they want it as an ordered pair, you'd write it as 3, 0. Make sure the x is the 3, so make sure it goes in the x position right there. All right, now for the y-intercept. We're going to plug a 0 in for the x. 2 times 0 is 0. And divide by 3. Y equals 2. Or if you need it as an ordered pair, 0, 2 in the y position. Make sure you keep those 2 answers separate. You do not want to bring them together. Your intercepts must have a 0. So never, let me write off to the side so we don't forget. Never write answers together. Like you never want to write 3, 2. You want to keep 3, 0 and 0, 2 as 2 separate answers. All right, the next one has a square in it, but we're going to set it up the same exact way. And you don't have to change the equation. Just the way it is, we're going to go ahead and plug it in. So our x-intercept, we're going to plug in 0 for y. And then we'll solve. So I'll need to get the x squared by itself. Now I need to get x by itself, so I'll square root. And I am not allowed to take the square root of a negative number. If you do in your calculator, it's going to get you an error message. So we're going to say none. And let's write a little note here. Can't square root negatives. So we don't have an x-intercept, but we still need to check for our y-intercept. Plugging a 0 in for the x. 0 squared is 0. And 0 plus 4 is 4. If you need it as an ordered pair, 0, 4. Example number 5. Again, we can leave it in this format. No need to switch the equation around. Plug in a 0 for the y. Minus 0 doesn't do anything, so I'll just go ahead and get rid of that. Square root both sides. And when we square root something in an equation, we will have to put a plus or minus sign. So if you wanted to write your answers as two separate numbers, you would have 5, 0, and then you would have negative 5, 0. Don't forget the plus or minus when you square root. We didn't need the plus or minus up here on example number 4 because you couldn't take the square root of negative 4, so no need for a plus or minus sign there. And your y-intercept, we'll do 0 squared minus y equals 25. 0 squared is nothing. You can go ahead and cancel that out. So now I have negative y equals 25. That's like having a 1 there. And divide by negative 1. As an ordered pair, 0, negative 25. All right, so that's intercepts. On the backside, we're going to talk about symmetry. So there are 3 types of symmetry we're going to talk about. The first is x-axis symmetry, which means you have the same thing reflected over your x-axis. So notice here is your x-axis. And what you have at the top is what you have at the bottom. What you have up is what you have down. So I'm going to write up, down, reflection. Now for this next part, this xy at the bottom here, I want to talk about a point. Let's say you have this point up here. That point is negative 3, 2. Again, I'm just naming where that point is located, negative 3, 2. If I reflected that point over the x-axis, went from up to down, it would end up right here, which would be negative 3, negative 2. The x is exactly the same, but the y changes. The x is exactly the same, but the y changes. That's what we mean by x negative y. The y changes. That works for every point along that graph. The x would stay the same, but the y would change. All right, let's take a look at y-axis symmetry. Here is the y-axis, and you can see you have the same thing right to left. So we'll write down right, left, reflection. What you see on the right is what you see on the left. And then we'll just pick a point over here, maybe this one. That one's 2, 6. And if you reflected that across the y-axis, moved it from the right side to the left side, you would get this point, which is the point negative 2, 6, because it's negative 2 and then up 6. So notice the x's are different, negative x. The y's are the same, leave it as a y. So as you look from one to the other, it's like you made the negative x, one positive, one negative, opposite signs there. All right, origin symmetry. It's a reflection over kind of a diagonal line. So we're going to call it a diagonal reflection. It's almost like flipping it over the x and the y. So you can think about almost having those two combined. Let's get a point here so we can see. What about this one, 1, 1? If I reflected that to the left and down, I would end up right here. Or if I reflected it diagonally, I would end up right there. That is the point negative 1, negative 1. So for your xy, 1, 1, if you want to reflect it over the origin, you would actually change the signs of both. Negative 1, or negative x, negative y. All right, so let's take a look at a couple of examples. based on the part above, see if you can determine whether each of these is x-axis, y-axis, or origin symmetry. I'll give you just a minute. Go ahead and try that part. You can always try drawing the axes in and see which one cuts the graph in half. So here I notice the same thing on the right and the left, which means the y-axis would cut it down the middle. This one I have the same thing in one corner as the opposite corner, so that's a reflection diagonally. So that would be origin. This graph, the x-axis cuts it down the center. And this one, this graph looks the same on the right as it does on the left. Right looks the same as the left. So that's going to be y-axis. All right, example number 7. Your job is to complete the graph so that it has whatever type of symmetry is mentioned below. I'll do the first one with you. So x-axis, we want to switch it over the x-axis, which is right here. X-axis symmetry means you're going to go up, down, up, down. So whatever dots you have above, you're going to bring them below. Just kind of flip the points down. You can even approximate it if you want to. As long as you have a part above, make sure you have a part below. See if you can do the same thing with the y-axis symmetry and the origin. All right, y-axis would be right here, and y-axis is right to left. So we would take our graph that's on the right, and we would, again, you could just kind of approximate it over to the left, right to left. The origin, think diagonally, so whatever is in quadrant 1 is going to end up in quadrant 3, all the way across the other side, something like that. If you get stuck on the origin, a good idea is to just take one of these points. Let's say we take this point right here. That is 1, 2, 3, 4, 2. And you would just want to plot the point -4, -2. Origin problems, both the x and y change. So 1, 2, 3, 4, 1 should have a point right there. That'll kind of give you an idea of where it was. All right, and the very last thing we're going to do is they're going to give us a point, and we're just going to change the x's and y's where we need to. So given the point 6, 2, we're going to find point symmetric to it, kind of like what we just did with this origin problem right there. So if it's over the x-axis, remember all the way up to the front, we're going to change the y value but keep the x the same. Change the y value but keep the x the same. So if you want to write a note, change the y. For the y-axis symmetry, you're going to change the x but leave the y the same. And for the origin, change both. Change the x, change the y. For example number 9, you already have one of your numbers as an x, as a negative. That's okay. Still go by the rule of changing the y, changing the x, changing both. So for the x, you're going to change the y, which means you're going to keep the x the same, which happens to be a negative, and change the y. For y-axis, you're going to change the x, leave the y. For origin, we change both. Change the signs of both. There we go.